All right, everyone. Good morning or good afternoon this afternoon to you all. And welcome to another section with Ansolution at TIPA Tutorial. I hope you are all present in class this morning or this afternoon. Let me hear your feedback if you are present in class. Anyone?
Yes, sir.
Yes, sir.
Okay.
Yes,
Good
sir.
afternoon,
Class.
sir.
Now, before I start this session, I would like to ask a question from you all. And my question goes this way. Is there any question you would like to ask me based on what we've done previously, or you have your own special question you want to ask me before I start this session? Ask your question now. Do you have any question? Any
Sir, good
questions? So
morning, sir.
I think it's afternoon now. Good
Yes.
afternoon.
Sir, should we ask from the past question?
You're free to ask from the past question. Don't worry. You're free to ask from the past question.
Okay, sir.
I'll take the past question. Okay?
Okay, good on, sir.
All right. What's your question?
Question. Should I tell you the page?
Yeah, tell me the page and the question.
Okay.
I do not.
78.
Question
Page,
70.
page 78.
Page 78. Okay? I'm on page 78 now.
Okay. Question 1, question 2, question 3.
All right. Now, earlier I said I'll take one question from the past question. So you are giving me question 1, question 2, question 3. It shows you are not well clear with the topic being treated that day, isn't it?
Yes, sir. Yes, sir.
Yeah, I can see 2 questions here of the same topics. Yeah, that's geometry or solid shape. Then one is of different topic, which is longitude and latitude. So you pick one question for me, then we address it. Which of the questions you want me to address?
Question 2.
Question 2.
Yes.
All right, question 2. Here comes the solution to question 2. Now the question says, what is the difference in the local time between two places in latitude 55° north? Now, we have, okay, let me finish up the question. It said, what is the difference in the local time between two places in latitude 55° north if they are located on longitude 8° west and 18° east, respectively? Now, this question is on longitude and latitude. Now, listen to the explanation so that you can have your solution. We are given the two places are on latitude. We have latitude 55° north. Then on longitude of 8° west and 18° east. Now, we are looking for difference in local time. Now, your question says difference in local time. Now, for me to answer this question, I will bring your idea back to longitude and latitude. That was the reason why I said I would take one question from the past question. Now, you have idea of what we call latitude and longitude. Now, lines of latitude are those smaller lines of the great equator. I repeat, they are those smaller lines of the great equator. Lines of longitude are those larger lines of the prime meridian. Lines of longitude are those larger lines of the prime meridian. Now, graphically, this is the Earth, spherical in shape. We call the vertical line at the center the Greenwich meridian. What we call the horizontal line at the center, the equator. Now, all other lines that fall horizontally are called lines of latitude. Are we there? Now, all other lines that fall vertically are called lines of longitude. I have differentiated what longitude and latitude is from this diagram. Now, how do we deal with local times? Whenever we are dealing with local times, it has to do with longitude. I repeat, whenever you are dealing with local time, it has to do with longitude. Now, what does longitude has to do with local time? Longitude says that when you have 1 degree, it is equivalent to 4 minutes. Longitude says that when you have 360 degree, it is equivalent to how many minutes do you have in an hour? That is 60 minutes. Are we good to go? 60 minutes. Okay. Now, a 360 degree says a complete revolution. So, sorry, a 360 degree says a complete revolution. That is 24 hours. Are we there? 24 hours. The earth rotates every 24 hours. Now, that tells you that what? For this question, we need to know the difference in longitude and the difference in latitude. So let's come to that first. Now, for longitude and latitude, for same place, for places located on the same latitude or longitude, on the same latitude or longitude, it means you differentiate. You find the difference of the two places. That is, we have 10-degree north and 50-degree north. That means these two places, you are to what? Subtract them. You are subtract them. They are located on the same latitude north. That's 50 minus 10, and that is what? 40. The difference between these two numbers are called angular difference in your longitude and latitude. Now, when they are on different places, like this one we have here, 8-degree west and 18-degree east, then you add them together. The angular difference is what? You add them together. Now, since you are adding them together, when you add 8 and 18 together, you have a total value of 18 plus 8, and that is what? 24 degrees. Now, we have 24 degrees there. And they asked us that what is the difference in local time? Now, the local time is the difference between the two longitude we have here, 8-degree and 18-degree. The angular difference between these two values are the addition of the
Okay.
two. You add 8 to 18, we have 24.
It's meant to be 26. 18 plus 8.
18 plus 8, 26. Thank you very much. So we have 26 here. Now, since we have 26 degree as the answer to the addition of these two values, then how do you get the local time? On longitude, I said that 1 degree equals to 4 minutes. Now, if 1 degree equals to 4 minutes, that means every 15 degree, you are having an hour, which is what? 60 minutes. Are we good to go? Now, is ever one we want to use out of these two scenarios, you have to be constant with the relationship. That is, if you are going with 1 degree for 4 minutes to get the value of the minute in 26 degrees, you have to be consistent with 1 degree to 4 minutes. If you are going with 15 degrees for 60 minutes, you have to be consistent with that. But the easiest one is 4 minutes. So I say, how many minutes do we have as the local time difference between these two places? Then that means 26 degrees equals to x minutes. Now, what will be the value of our x? Then you cross multiply x equals to 4 times 26. And the final answer is 4 times 6 is 24. 4 times 2 is 8. That is 104 minutes. Do we have 104 minutes in the option?
Yes, sir.
Yes, that's your answer. So
Thank you, sir.
that is that about your question. So let us focus on what we have today. Any other student with the next question can bring the question in the next class. Is that clear?
Okay, sir.
Okay. Today's class, I asked for your suggestion on topics you guys had not treated, and we come into conclusion to pick trigonometry. Are you aware of that?
Sir, please, I'm not seeing the board.
You are what?
I'm not seeing the boards, please. Just
Hey, sorry. Sorry. Okay, now you can see the board.
yes, sir.
Now, I said we picked a topic earlier this morning, and that is trigonometry. I believe you guys are aware.
Yes, sir.
Yes, sir.
Now, starting that trigonometry, and I want your full attention. For those who are using the board, can I rub the board?
Yes, sir.
Yes,
No,
sir.
Okay. The word trigonometry arises from the word tri, which is three sides. Trigonometry says you use the word metry, which is the study. So when you use trigo, you are using triangle. Trigo means triangle. Metry means study. So that means we study triangle in trigonometry. I believe you are aware of that. That is the
sir, please, can
breakdown
you come again?
now. Trigonometry. Three. Trigo means triangle. Metry means study. We are studying triangle in today's section. I believe you are aware. So here comes a triangle. We have different type of triangle, but the triangle we are dealing with here is called an equilateral triangle. An equilateral triangle. We have equilateral triangle A, B, and C with equal side 2 units, 2 units, 2 units, and equal angle 60 degree, 60 degree, 60 degree. Sum of angle in a triangle equals to 180 degree. Now, if you divide 180 into 3, you have different angle of 60, 60, and 60. Now, an equilateral triangle has equal side, equal angle. Now, for this topic, I will be very, very quick with my explanation because I expect you to know some parts and I expect you to be aware of some parts also. So, the part of so, ka, twa, introduce us to what we call trig ratio. Trigonometry ratio. Now, they will be testing your skills on this aspect. So, katwa, trigonometry ratio. Now, what does trigonometry ratio talks about? It says when you define sine of an angle, it is defined as the opposite of that angle over the hypotenuse of the angle. When you define cosine of an angle, it is defined as the adjacent of that angle over the hypotenuse of the angle. When you define the tangent of an angle, then it is defined as the opposite of that angle over the adjacent of an angle. Now, having tested your skills on this aspect, they can as well test your skills on the inverse of this aspect, but I will limit our scope to the trig ratio, sine, cosine, and tangent. Then, in the course of explaining, then I will introduce you guys to the inverse of the trig ratio. Now, how did you come about the sine, cosine, and tangent of some angle? We have the trig ratio of simple angles. we have the trig ratio of compound angles. Those compound angles are called double angles. Now, simple angles that we have simple angles like 30, 45, 60. Those are simple angles. Compound angles are angles like 15, 75, 105, 135, 225, 275, 135, and so on and so forth. Angles that whenever you are adding two or more simple angles, you will always get them are called compound or double angle. I have made myself clear with the difference between simple angle and double angles. Now,
So can you please repeat the single angles?
what did you say?
Can you please repeat the single angles?
Okay, the simple angles that we have, they are simple angles that we have are angles that you can find with or without calculator. They are angles like angle 30 degree, angle 45 degree, angle 60 degree. Now, all these angles, you can find their trig ratio with or without calculator. Are we there? Now, we have compound angles. Compound angles. These are angles that whenever you are adding or subtracting two of these simple angles, you will get them. Now, angles like 30 minus 45, I have angle 15 degree. Angles like 30 plus 45, I have 75 degree. Angles like 60 plus 45, I have 105 degree. Angles like 60 plus 30, I have 90. Okay, so 90 can come before 105. So I have 90, 105 degree, and etc., etc. Those are compound angles. Now, I will give you a table for simple angle. And with this table, we can use the idea of the simple angle to get the trig ratio for compound angles. Time may not permit us to solve questions from the past question, but I want that time to be permitted for us to understand that logic behind trig ratio. Now, here comes the idea of simple angles. For a equilateral triangle, when you bisect a triangle into two, you cut it into two equal halves like this. Then that means you see this 2 unit has been divided into two. 1 unit, 1 unit. Another thing is divided into two. That is what? 60 degree into 30 degree, 30 degree. Now, you pick one bisection of your triangle, and that is what? Half of the triangle. So I pick 30, I pick 60, then I pick angle 90 at the bisection. Here is side 2, here is side 1. We can find this one using Pythagoras theorem. And if you use Pythagoras theorem, x here equals to square root of 2 square plus 1 square. And x here end up giving us square root of 4 plus 1. Yes? No. This is hypotenuse. So here it is minus. Minus. Here it is minus. So here becomes x equals to square root of 3. So the value of x here becomes root 3. Now, take note of something here, that the Pythagoras theorems that we use here involve addition. Here it is, hypotenuse square equals to opposite square plus adjacent square. Now, you can only know your opposite square if you have your angle given to you. Now, we have a new angle 30, so we use this angle 30. Opposite is 1, adjacent is x, so the hypotenuse is 2. So when you make x subject of formula, that is where your minus is coming into play. Here, I have explained that angle. So now, I have 30, I have 60. Let me give you the diagram of trig ratio for simple angle 30 and 60. So you can see that what everything you are doing with your calculator, you can also do it with your head. Now, here comes a table. Let me give you the table to this side here. So I have let me use a sign. So I have angles like 30 degrees. So I have sine, I have cosine, and I have tangent. So we start with 30. Now, for 30, when they say sine 30, it says what? Opposite over hypotenuse. Now, sine 30, the side facing 30 is your opposite. The side under 30 is your adjacent. The longer side is always your hypotenuse. I come again for 60. The side facing 60 is your opposite. The side under 60 is your adjacent. The longest side is always your hypotenuse. Now, class, if you press your calculator for sine 30, you will end up having 1/2, which is 0.5 from that calculator. If you press your calculator, anyone calling my attention?
Sorry, sir. What about 90 degree?
90 degrees. 90 degrees is a simple angle, but you can never get the tangent of 90 degrees. That is why I did not include 90 degrees for a simple angle. I only included 90 degrees for a compound angle because you can add 30 and 60 to get 90. Is that clear?
Okay, sir.
Okay. Now, if you check your calculator for cos 60, you will have √3/2, and that is the same as 0.8660. Then the last one is the tangent of 30. Tangent of 30 says that it is the opposite over adjacent, and that is 1/√3. Now, with this one in a short form, I will write it as √3/3. It's still the same thing, but let me put it as what you can see, 1/√3. And 1/√3, you should have 1.7321. Yes, if you check your calculator. That is that about 30. Now, there is a logic behind 30 and 60 that I want you to see. Because every value you arrive at for sine 30, you will get the same value for cos 60. Every value you arrive at for cos 30, you will get the same value as what sine 60. That comes, 60 degrees. Now, for 60 degrees, sine 60 is the same as √3/2. Cos 60 is the same as 1/2. But tan 60 is the only different thing. That is √3. Because opposite over adjacent, √3/1 is still the same as √3. That is why we have this one as √3. Now, the last simple angle that I want to introduce is 45 degrees. But you cannot find 45 degrees here. You cannot find 45 degrees here. We can find 45 degrees from a new diagram. Now, that is a quadrilateral shape. Now, let me give you a quadrilateral shape here. Can I view this place here? Okay. So here is a quadrilateral with all sides equal. 1 unit, 1 unit, 1 unit, 1 unit. Now, angle 90, angle 90, angle 90, angle 90. We bisect an equilateral triangle vertically, but we can only bisect a quadrilateral or diagonally. So when you bisect this way. Now, bisecting this way, we have an unknown value y here. Now, we pick up a new value. Here is bisection into 245. Here is bisection into 245. So we pick a new shape this way. 1, 1. Then we look for this man. Y. This is 90. There, 45. Here is 45. Now, we use the same Pythagoras theorem. Y squared equals to 1 squared plus 1 squared. So I can say y equals to square root of 1 plus 1. Then my y is √2. So if my y equals to √2, now here comes the solution of 45. 45. Sine 45 is the same as cos 45. So I have sine 45 is 1/√2. Cos 45 is 1/√2. But tan 45 is the only different thing, and that is 1. Those are the simple angles that we can talk about. when it comes to trigonometry. Now, you see the diagram of this table I have on the board here. I want you to master them. Yes, know your trig ratio without calculator. Know your trig ratio without calculator, because I can vividly tell you sine, cosine, and tangent without pressing the calculator. And I can also solve for compound angle without solving using my calculator also. So I will only show you for two compound angle. They won't ask you question on how to derive that, but they will ask you to get the answer. Okay, I will show you for two compound angle, and the two compound angles are 15 and 105. I repeat, 15 and 105. 15 and 105. Those are the two compound angle I will show you. Then others, you can now go and check for them yourself. Is that clear? So I can rub this part on the board because we are going to be needing the board this time. So here comes the compound angle. You see, in the case of compound angle, there is something you need to be aware of. Trig identity. I repeat, trig identity. If you don't know the trig identity, it is advisable you learn them. Now, trig identity. Trig identities. Identities. Now, there are three basic trig identities that you need to be aware of. Now, what are those three basic trig identities? I will show you the derivative of those three, so you can know that what they are not new. The first one says it's coming from Pythagoras theorem. Recall, Pythagoras theorem says hypotenuse square equals to opposite square plus adjacent square. You are aware of this. Now, we want to derive the three identities. Now, the first trig identity says that what? Divide all through by hypotenuse square. Divide all through by hypotenuse square. So that means here becomes all square equals opposite over hypotenuse all square plus adjacent over hypotenuse all square. Now, from here, this divided by this is 1 square. Opposite over hypotenuse is sine square. Then plus adjacent over hypotenuse is cos square. So here is the first identity that says that what? Sine square theta, cos square theta is the same as 1. Let me write it very well for you so you can know that 1 equals to sine square theta plus cos square theta. Here is the first identity. Now, for the next identity, we say recall from this same Pythagoras theorem. From this same Pythagoras theorem, divide all through by opposite the next value. Opposite the next value. Opposite the next value. Opposite the next value. Divide all through by opposite square. So here becomes hypotenuse over opposite all square equals to opposite over opposite all square, then plus adjacent over opposite all square. Now, here comes the inverse of the trig ratio I was telling you about. Here comes the inverse of the trig ratio I was telling you about. From here, hypotenuse over opposite. Here is opposite over hypotenuse. That tells you that what? I am inversing my sign here, all square. 1 equals to opposite over opposite is 1, all square. Then plus adjacent over opposite is here. Do we have adjacent over opposite? Yes, we only have opposite over adjacent. So I am inversing my tan here, all square. So this math says that the name given to the inverse of sine is cosec. All square equals to 1 square plus the name given to inverse of tan is cot. All square. So automatically, the second trig identity says cosec square theta equals to 1 plus cos square theta. Here is the second trig identity. You
I
must
don't
never.
understand.
Yes.
So I don't understand the part. How did you get? I understand this step 1, 2, but that step 3, 1 over sine. Yes, that
Yes.
part. I don't know how it led to the other step.
1 over sine. 1 over sine is the name given to the inverse of sine. And the
Okay, sir.
inverse of sine is called cosec. Are we there?
Yes, sir.
Now,
So you
let
really
me.
like make it naturally, or you just gave it the name?
It's natural. It's natural. It's natural. So here becomes cosec. Cosec theta says it is 1 over sine theta. Secant. Okay. Let me use the full name. Cosecant. Cosecant theta equals to 1 over sine theta. Secant theta equals to 1 over cos theta. Then cotangent. Cotangent equals to 1 over tan theta. Now, these ones are what I am introducing here. 1 over sine is cosec. This is the cosec. 1 over tan is cotangent. This is the cot. Is it clear now?
Yes.
Now, that is the second trig identity you must never forget. The third one of its kind. The third one of its kind says that this one, you divide all through by adjacent.
Sir,
You
sir,
divide.
please.
Yes.
I was not done with writing this.
Okay. You should just go with the idea of this third one. Then you understand. Okay. I think this class is recorded. You can also check the video also. Is that clear? So the third one divided through by adjacent all square. So I have hypotenuse over adjacent all square equals to opposite over adjacent all square plus adjacent over
So the board is
adjacent.
blurry.
The board is,
Blurry.
how about now?
Still
How
blurry.
about
It's still blurry. Oh.
eh,
Still blurry.
from here? I guess it's the network. Okay, just hold on a bit, it will be clear. It's the network.
It's getting clear.
So let's continue. It's a recorded class, so you can watch the video after. Is that clear? So here I have hypotenuse over adjacent, this case. This is the inverse of this man here. So I say 1 over cos all square equals to opposite over adjacent, which is tan. I can say tan square. Then plus adjacent over adjacent is 1 square. Then bringing the name of inverse of cos, I have sec square equals to tan square, then plus 1 square. So this is the third identity you must never forget. Sec square theta equals to tan square theta plus 1. Class, even if I am not using this one to solve questions for today's class, in the next class, I'll be solving questions with this identity. So I want you to have idea of trigonometry today. Don't worry about we not solving questions, okay? Just have the idea of trigonometry today. And if you don't understand anything, watch this video again. I am very much sure this video is very interactive and learnable. Now, this is the third trig identity you must never forget. Now, having those three identity, there is one other identity that you need to know, but you don't have any idea of it. It is called compound identities. Now, you see that compound identity, I will only list them here. I will list them here. Then you can use your own idea on your own. Learn them. Then in the next class, I'll show you how you can use them to solve for compound angles. So let's go with the compound identities before my time runs out. Here we have identities like sine A plus B adding two angles together. Adding two angles together. So I can rub all this part because it can be extended. So here comes this. I have sine A cos B. That's plus cos A sine B. So that means if you are subtracting also, that means here will be subtracted. I have cos A plus or minus B. Now, this one is a different case entirely. Cos A, cos B, minus sine A, sine B. Now, if you are subtracting here, it is addition here. Then for the last one, tan A plus or minus tan B. It says that tan A plus tan B over 1 minus tan A tan B. So if you are subtracting, there is minus, here will be plus. Now, I will end this section with the identity for today. Just read, watch the video again and understand. So in the next class, I'll show you how you can use them to solve questions. So you guys can enjoy the rest of the day. See you in the next class.